Alright, here we are again. Another Draft Physics video production. Alright, some comments. And then back to whatever his name is. Yeah. Stanford. Forget his name. Anyway, it doesn't really matter. It doesn't really matter. Nothing really matters. This conversation is somewhat impossible, it seems. Alright, so this is John Robbins defending Ken Wheeler. Alright. He never says there's no such thing as a wave. Well, I believe you can find plenty of references where he says, there's no wave. Wave in what? All of this kind of crap. Implying that the word wave is somehow not appropriate to describe objects that we know, like a wave. Like somehow the word doesn't make sense. And the word makes perfectly good sense for us to describe the concept of a wave. So his argument is kind of stupid to say when they say photons are waves, he should say, yes, they got that part right. Right? If he believes everything is a wave, then he should just say, yes, they got that part right. They just don't understand what it's waving in. They call it a field, and it's not a field. Or something like that. He just should point out, well, that's the ether. If that's what he believes. But he doesn't say any of that. He says stupid things like there's no such thing as a photon, when the idea of the thing, whatever you want to call it, the energy, moving from one place from point A to point B, is the concept we're called a photon. The specifics of what that photon is a little bit ambiguous depending on what physicist you talk to. So, well, anyway, he never says there's no such thing as a wave. He believes everything is waves. So why can't he draw these waves? Why can't he show us how they're waving? He said light's a coaxial cable. How is a coaxial cable anything like a wave? Just explain that to me, all right? Do I just explain how a coaxial cable is something like a wave? Because I can't see anything. I can't see how it's like it at all. I can't see how I can possibly make a photon into a coaxial cable. It's just crazy. It's gibberish. So again, don't tell me that I'm listening badly. He's talking badly. He's not using regular conceptual words. We have them for a purpose. Flat thing, light thing, heavy thing. These are good words. And he's playing some game like the words don't mean anything. So fuck you. He also does believe in atoms. Well, why doesn't he draw an atom for a change then? Show me what he thinks an atom is. What? What? Again, why can't you draw? You can draw things that have waves on them. If everything's a wave, then draw the waves and explain to me why the little wave stuff, the goo, decides to hyperboloid. I mean, he doesn't provide any explanation. If something curves inside of an atom, if something's spinning, you have to explain why it's doing it, just as much as you have to explain why the Earth is going around the sun. They both demand explanation, and he provides none, and then points his finger at other people who have one that's stupid, and says they're stupid. Well, he doesn't have an explanation, so he's just as dumb. Alright. Just not electron or photon. So does that make any sense? What about protons? Does he believe in them? I mean, charge is fundamental to all the experiments. If you want to pretend charge doesn't exist, like the D. Hilsters, you're an idiot. I'm sorry, it's just too fucking stupid. You obviously don't know anything about the evidence that exists if you don't think charge exists, because it's everywhere. So that's just fucking stupid. So you can't take away the existence of the things creating it. Well, I don't know, you want to make it the electron into some jellyfish, that's okay with me. But you can't deny the fact that it's charged somehow. Somehow it's doing the opposite that the proton's doing as it interacts in a field. So whatever the thing, the goo is doing, whatever the fucking ether's doing, whatever you fucking want to call it, the stuff outside of the thing you called an atom, somehow these two things react entirely oppositely to whatever that crap is. And you have to account for it. You don't actually listen to what he's saying. Now, fuck you. So that's just such bullshit. I mean, I don't know how that kind of crap comes out of your mouth. I'm not listening wrong. He's talking wrong. If you can't understand how this isn't that complicated, all right? I mean, you're going to explain a kid riding a bicycle down a street. You don't just there and say, well, it's like a coaxial cable except inverted and without any magnitude. Well, what the fuck are you talking about? There's two wheels, there's pedals. The kid ate food to get energy. I mean, that's the real explanation. Why can't he just put it into real words and explain as a kid riding a bicycle? Okay, it's a shame you don't have the mind to understand. It's a shame you're such a despicable piece of crap that you'd sit there and be this dishonest in your evaluation of the failure to communicate here. Like somehow I have to be what? This is worse than a Jesus story. This is worse than a religious story. It's like a coaxial cable. And then there was, when God created light, and then there was coaxial cable everywhere for everyone. What the fuck are you talking about? Fuck you. Dude, these people are just belligerently retarded. You're just trying to be a jerk, right? Yeah. Alright, so then the rest of the comments are just really jokes. And, fine. It's not much better, to tell you the truth. It's not much better than Ken Wheeler just laughing. Where do the electrons go? Where do they come from? Where do they go? This is his latest video, right? He's mocking the idea of magnetism creating electricity in a coil, basically a transformer, and he's implying as somehow regular physics says the electrons just move and there's no such thing as like a ground and the positive end. Like, he doesn't even understand what Tesla knew, that you pull the stuff out of the ground, okay, that charge goes in or out of the ground. And he doesn't even acknowledge that at least physics knows that much, that the ground wire is where the electrons are coming from when you're spewing them out the other end. So if you buy the electron moving argument that somehow we're moving electrons, see, I'm arguing that you're just moving pressure, okay? So you don't really move the electrons to another location. You don't send a bunch of extra electrons. All you're really sending is pressure. You're pressurizing the atoms, depressurizing atoms. That's all you're really doing. And that's why there's not a fundamentally huge difference between DC electricity and AC electricity, is because all you're really doing is changing the atom, pressurizing, depressurizing, changing its state. But regardless, if you think the electrons flow, it's perfectly valid in the sense that it still works, because the electrons obviously come from the ground into the copper wire and go through the copper wire and get pushed out the other end as positive voltage. So again, his argument is just, it totally misses what is being said. He's just straw-manning the conventional theory and pretending they haven't accounted for where the electrons come from, when of course they have accounted for where they come from. It's got a little symbol, ground symbol. But anyway, so this is just, a bunch of poetry, and that's fine. Okay, you want to make jokes, it's okay with me, I don't care. But whatever, I'm not terribly interested in joking Ken Wheeler into the ground. I want to pound him in with facts and pointing out how he's a lying sack of scum. Alright, fun fact. This is an NSA SAT video of the STS video in the 90s. Yeah, I watched it on cable, I remember at the time, actually. I actually watched it, when they were doing the experiment. They put this really long wire and the wire broke. Because they got more voltage than they thought they would. They didn't count for the amperage, and the amperage burned the wire. So what? And so he's implying, so there's no link here. He's implying, okay, let's just read this. As it floats off into space, look what swarms around it. Swims around. It looks like someone dropped a worm in a pond of minnows. Pay attention to the center of the objects. Same as the magnet. Sorry, no fucking clue what you're talking about. Same as a black hole. You've seen one of those too, have you? Now, why would that be happening? What are you talking about? What could be its propulsion system? The propulsion is from the breaking of the wire and the huge amount of tension caused in the wire by the fact that it's 15 miles long, you idiot. And it's tied to a spaceship moving. Gee, I wonder. Yeah, I don't know. A bunch of empty wonderings, ponders. You think there's something NASA hasn't explained in these images of the wire floating off. Well, then you're a deluded kook. A truther loony. What is that? Again, so no link, and just a bunch of rhetorical questions that make assumptions that haven't been demonstrated to be worth assuming. So, fuck you. It's no fun fact there. Effing moronic. Water in a pond not the same as magnets. Unreal idiocy. Well, I guess his argument is somehow this waving thing. Like, when you're causing the water to wave, you're not waving. So somehow you can't cause the thing causing the wave is somehow not the wave. Well, I think everybody knows that. But the fact that it's motion, and motion causes motion, and causes motion causes motion. So, I don't know. I mean, I guess I agree with your point, but I suppose it's semi-valid to point out you still have to explain the cause of the wave, but I don't know where Ken Wheeler ever does that either, so he never points out why something's waving. Funner fact, it's not how many views, well, yeah it is, it's what you can back up with facts. I wish that's the way it was, but I'm just saying it just really doesn't matter. The point is that you have to communicate in the world that exists, and so clearly I'm not doing that effectively, and there's just no denying that. We are avatars. Concave Earth. Okay, so just more blah, 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 jokey kind of rhetoric. Fine, whatever, blah, blah, blah. Alright, so enough of that. Back to this guy. I don't know why his name doesn't just Leonard Susskind right there. I emboldened it, trying to stick it in my head. So we'll just continue with this in the context of, so he's giving you the explanation for why they have these basic beliefs in quantum mechanics. He's citing some experiments, but very few. Just giving you kind of a history of the assumptions or conclusions drawn. And so he's talking about the wave-particle duality thing, in a sense. He's getting to it. And even the word particle, he's playing with it, trying to, and I'm just saying that you can just see how mushy how it just teetered on some sort of thing, and they just decided to go heads or they decided to go tails for kind of arbitrary reasons. And that's sort of the mistake here, is drawing conclusions before the evidence tells you something, and then using the slightest evidence to verify a prediction. Like it's even just a little bit like what you predicted, and therefore you validated your theory. When, you should require more than that as scientists. And so I'm just kind of attempting to demonstrate how, look, the basic concepts, I'm not denying experiments. I'm not denying, that certain experiments have been done and they have certain results. I'm certainly denying that the only way to interpret those results is the way they've done. Just like the two-slit experiment and the single impediment experiment sort of demonstrates that it's about surfaces, not about slits. It's not about openings or obstructions even. It's about surfaces. And that's all it's about. And that surfaces do things. And then they have the corroborating evidence of knowing that, in transparent media, we know that surfaces cause diffraction. It cause the light to bend. And it bends all the same way. And so you can just think to yourself, well, if you're going through the surface this way, it bends a certain amount. Well, you could think that if it goes through this surface this way, that it might bend that amount, and then that amount again, and then that amount again, and then that amount again. So anyway, I mean, they just gave up on. I mean, they have multiple ways of looking at it, and they do this process of elimination way too fast, way too casually, and it's led them to, create a foundation that's messy, and everything they've built on that foundation is therefore in jeopardy because of that bad foundation.
That everything was made out of these 92 elements. So they were the elementary particles. Now, sort of all hell broke loose in the beginning of the 20th century, very, very end of the 19th century, when some discoveries were made. The electron was discovered. About 3 years, I think, before the turn of the century. I don't know exactly when it was. The electron was discovered, and a number of other things were discovered, but in particular, radioactivity was discovered. Radioactivity was the first real signal of the thing which was later going to become nuclear physics, and nuclear physics and particle physics, and had all the things that needed to...
Yes, the understanding that the atom wasn't the atom, that they were sort of wrong to give it the title atom because it wasn't the smallest thing. The smallest thing was the atom had more shit in it, and so they hadn't looked deep enough, so they had to fix that. And of course, they didn't fix it. They didn't say unatom, pseudo-atom. They didn't do anything to change the rhetoric. So again, they recognized the mistake but didn't fix it.
Be explained sort of there in a sort of tiny little version. So let me just remind you about radioactivity just for fun.
So then we had to come up with words like subatomic, right? Subatom. Not great.
Who discovered radioactivity? I don't even remember. I don't think it was Marie Curie who discovered radioactivity. I don't think so.
Yeah, she discovered radium. Yes, but it was actually somebody I think who worked in the same lab as her and who discovered it in the sense that he had photographic plates in a drawer and he put a bunch of ore in the drawer and the plates were ruined. And so he decided to figure out why. Yeah. And he figured it out. The rocks were doing it.
Becquerel? I think it was Becquerel. Yeah. No, it was Marie Curie. What she did was, lots and lots of experiments to pin it down with great, but it was Becquerel. And he had a chunk of lead. Don't ask me why he did this. I do not know. He had
Yeah, you do know why he did it. So again, it's just kind of funny. He did it exactly because he knew there was something coming off of these rocks that was exposing the plates, and he wanted to find out what it was, and this is one of the ways you find out.
Chunk of lead, and a little hole in the chunk of lead like that, and some material down here. Radioactive. I guess the first thing that happened was he had some radioactive material, presumably radium or something like it, in his laboratory, and he had a photographic plate, and accidentally the photographic plate happened to be near the material, not here, over here, material, photographic plate, and the photographic plate got ruined. Got ruined by the presence of the radioactive material. The radioactive material...
Yeah, so he knows the story. So I don't know why he said he doesn't know the story, right? So it's just all just kind of thrown together. They see, everybody just has their own little bits of reality they keep. And, that builds their structure, their view of the world. And that's all I'm trying to have a conversation about, is that I have this honest perception of the world. Okay, I'm giving you how it works. And so I have these elements in it from just even childhood, of the idea that photons can't be doing this nonsense. It just doesn't make any sense. There's no explanation for how they're a thing. Okay, they're not a byproduct of something. They're the thing that's going from point A to point B. They're the thing that has the momentum, and How is the field doing anything to them as they travel? That doesn't make any sense. The field's not making a photon by a magnetic field coming this way and then an electric field doing something like this. The fields aren't creating it from these locations. The photon came from over here. It came from the antenna. It came from the flashlight. How is the atmosphere doing any of this stuff? And just because I can't make any sense of their drawing is why I have to sit there and draw something else. I have to make those dots connect. And the dot I have there just doesn't make any sense at all. I can't accept the existence of this dot they've put there. And so I'm saying, no, I don't see a flamingo. I see a water buffalo, because that dot is just wrong.
Ruined, was like light shining on it and ruined the photographic plate. Anybody else, or not anybody else, probably me, would have just thrown away the plate and said, this is ruined, let's find another plate, and start the experiment over again. But Becquerel realized he had discovered something.
So, yes, you're not an experimenter, I guess, or an engineer type, or somebody who asks questions, and that's the whole problem. You don't ask any questions, you just accept.
Discovered that radioactive materials do something to the photographic plate as if they had been illuminated by some radiation. So he decided to study that radiation a little bit better, and he put the source of it deep in a block of lead. How he knew to use lead, I do not know, but lead was a good substance because it was very dense.
So again, he says he doesn't know, but clearly the way he knew is because he found he could block the radiation with lead. So he already knew that this works to block it. The photographic plates don't get exposed if I put lead in between. I mean, shit, how he knew, I don't know. That's how he knew.
And he put it into a hole, drilled into the lead, and then put his photographic plate out here, and wanted to see whether it would illuminate a single spot over here. Everything was collimated by this hole. He wanted to see whether it would...
So again, this idea that it's collimated by the hole isn't really true, okay, because it's reflecting off the sides of the hole, so it's not exactly going to come out as parallel rays. So that's sort of a misnomer or a something or other. You don't collimate by creating a cylinder all by itself. And this is one of those things where you say, wouldn't you ask some questions about what exactly happens when something's sitting there and it's got to shoot out through a tube and it's going to radiate in 180 degrees from where it's sitting. And so there's stuff coming out at all kinds of angles, and it's not going to be able to get through all the lead, and it's going to get absorbed, and at the same time it's going to reflect some of it, some portion of the radiation.
Create a sharp little spot as if something were coming up out of this hole. And indeed it did. So he got the idea that a beam of some sort was being ejected, or something was being ejected by this radioactive material and being collimated along a beam. That was the first particle beam. That was the first beam of particles. What was it? He had no idea what it was. But then I guess a second fortuitous...
So most of it would go in one spot, but there would be, what you'd expect in some scattering from the fact that it's reflecting some portion of it.
Just accident. I think it was an accident. Again, I'm making up the history as I go along, but it's close to the truth. He happened to have a magnet in the laboratory. And for some reason, the magnet was in a position here where a magnetic field was created.
I'm sure he did that all on purpose. So again, this is, it's like he didn't spend 5 minutes doing this. He spent days doing it, kind of thing. And he tried all kinds of things. He tried probably putting a vial of water, and this and that. Tried different things to see what would happen.
Here where these particles were being ejected. And what happened when he put the magnetic field, when he put the magnet near this, is the beam split into three separate beams. Three separate beams. One went straight ahead.
So he obviously put one pole of the magnet, right? He pointed to the magnet, so it's not like he's put any old magnet. He put the north or the south side of the magnet pointing towards the beam, alongside the beam.
Just as if the magnetic field was not there. One of them got deviated to the left, and one of them got deviated to the right. Left, right, left, whatever. One deviated more than the other, in fact. They were not symmetric.
Right, now, if there were all these positrons that are supposed to exist and all this other stuff, then should be more than one beam. There should be one over here that's positrons, because they'd get deflected a lot more because they're so light and they have the same charge, so they would go way over here. And you should have a whole bunch of different beams representing all these dopey particles they say exist somewhere in atoms.
And Becquerel, or somebody, whoever was around, knew enough to realize that beams of particles, trajectories of particles, get bent by magnetic forces. If you have a magnet and you have a charged particle, the charged particle goes through the magnetic field and either bends to the right or to the left, depending on the sign of the magnetic field.
Right, so it's just a great experiment. I mean, in the sense that this really is, this was the first nuclear physics, the first subatomic, in the sense that now you see it and it's right there in front of you, okay? Plus, minus, and not charged, which is the force bits, the light bits. And you could probably see the difference in terms of the patterns they left on the photographic film. It'd be great if we actually saw some of that stuff, like saw the evidence of it. Or, you could, just link to that experiment being done today and just show us what it looks like. How many particles go one way and how many go the other way in terms of how much energy ends up in the different locations would also be interesting. I mean, if protons are 2,000 times as massive, do they leave more of an impact or less of an impact?
And the charge of the particle. So if the particle was a positively charged particle, it would bend one way in the magnetic field. If it was a negatively charged particle, it would bend the other way in the magnetic field. And what Becquerel had found is that there were three kinds of radiation. One behaving as if it was composed of electrically neutral particles. Which one was electrically neutral? The one that wasn't deviated at all. Of course, he didn't know they were particles. All he knew is that some collimated effect happened that illuminated the detector, the screen, the photographic plate.
The bits. Yes, he knew they were bits. I'd say that much.
One of them got deviated to the right, as if it were a negatively charged particle. He called that component of the radiation, he called that component beta. The component that went straight ahead, he called gamma. And the component that deviated in the other direction, as if it were positively charged, he called alpha. These became the three distinct kinds of radioactive effects. The three.
I suppose you could say some neutrons go straight, but again, it's a little bit complicated. I don't want to say anything further on photons. So again, the idea will be just these words we use. So let's just understand, we say proton, we say electron, and then we say photon, as if a photon is a singular thing, when the photon is different in the sense it's force, it's moving the speed of light, it's not matter, it doesn't have mass, traditional mass. It won't be bent by gravity. So it's just, but that's where it starts to go wrong, is when they got to label things right. And when you don't even label them right, you just keep a bad label. Photon was a bad label because it's obviously not a ton.
Distinct kinds of radioactivity: beta radioactivity, gamma and alpha. Just again, I'm not interested in making suspense here.
Well, I shouldn't even say it's not, right? The element of it is a ton, right? The quanton, or whatever you want to call it, the element of momentum inside the photon, the elements of that momentum inside of a ray that is a photon. But just to see how it's so destructive to just a casual conversation about physics to say something like photon and electron and those things, just you're giving them too much commonality, too much in common, too much similar about them, when fundamentally the photon has to be understood as little tiny bits that are small, like the electron is small compared to a baseball, or the atom even. The photon is small to the electron, and it's a bunch of little bits that make a ray that we call a photon.
Let me just tell you what they were. You probably know what they were. Many of you know what they were. Beta was electrons, negatively charged particles, which were just the electrons that had already been previously discovered in cathode ray tubes and that kind of thing. And these were electrons coming out. The alpha particles, we now understand, and at that time there was no precedent for it, that they are helium nuclei. Protons and 2 neutrons stuck together. Atomic number 4. Both helium.
Oh crap! Damn audio again. Shit. Yeah. So the protons aren't free protons because they're still in the form of nucleuses in radioactive decay. So in radioactive decay, the protons aren't liberated individually. They're liberated as a nuclei.
He didn't. He would have said helium was number 4 on his integer collection of materials, and gamma are.
So let's understand. In the nucleus, the helium, the protons are bound to each other, as I've sort of tried to explain, because of neutrons. Because neutrons have an electron, and the electron, all the energy. There's not a strong force that holds protons together. It's the absence of force. It's the forces all leaks out because of the opposite charges, and so protons can get really close to each other because they have an electron in between them. So they get very close, and that bond doesn't get broke in decay. So when the atom breaks down and falls apart, the hunks of the nucleus are still intact because they have a very strong force between them called that electron. That electron just keeps leaking the force out, so the two stay very close together.
Photons. Okay, electrically neutral, no electricity at all. And these 3 kinds of. Now, I think he did, again, I don't remember the history, but he might have had a sufficiently dilute source that these particles arrived one at a time at their destination. In that case, he would not have seen a bright.
Right. So I'm sure he noticed that the longer he exposed the film, the more consistent the image got, or the less fuzzy it got, and that the least he exposed the film, it just had little dots on it. So he knew they were corpuscles, they were rays, they were individual hits. They weren't some they weren't something other than little bits of stuff with momentum.
Right spot over here, he would have seen blip, 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 illumination occurring, or spots occurring, discrete little spots occurring for the electrons. And he might have said, oh, those are particles. Particles arriving one at a time, illuminating the screen discretely. He would have done exactly the same thing for the alpha particles. He would have found that the alpha particles arrived one at a time. In other words, he could have used, imagine, they probably did, use the screen here as a counter, analogous to a Geiger counter or something. Whether he did or not, I don't know, but it's something you can imagine, that he detected the particles coming one at a time. That would certainly be feasible with a Geiger.
Right. So this is, I'm just saying that we all play with what history we know and how deeply we know it and what we know it from and what sources we got it from. And all of that should be pretty securely factual. And that's part of the problem with these conversations about physics is a lot of stuff is thrown in there that isn't real. And citation to experiments, like all the detector experiments. Every time somebody talks about a detector in a 2-slit experiment, they're talking about an experiment that hasn't been done.
Geiger counter, and so evidence that whatever this radiation is, it's coming in discrete little bundles that we could call particles. What about gamma? Same thing for gamma. Gamma is coming one at a time, but at that time, Becquerel had no idea, neither did anybody else, what gamma was. It was uncharged, that was all that was known, and it illuminated the screen just as the others did. Okay.
Yeah, that was sort of found out later by Curie, who did the radium experiment. And the funny part is that if it wasn't for the fact that it made light, they would have thought they didn't find radium, because it was so small. This was such a small amount that created so much radiation, that that they thought they didn't have any, and so no, it's such a small amount that's in the ore, so it's really hard to get a lot of radium, and so they thought they didn't have any. And if it wasn't for the fact that at night the dish that they thought that stuff was supposed to be in glowed, they wouldn't have known they discovered it. So if it didn't glow, they would have thought they failed to find, they failed to dilute it out of the solution, because there was, after they went through this whole process of reducing the ore and separating every other element out of it to try to get radium, there was nothing in the dish, but the dish glowed, and that's what gave it away.
That was, as I said, in some sense, the first particle physics experiment. We'll come to some later particle physics experiments soon enough. Let's next talk about electromagnetic radiation. Ordinary electromagnetic radiation.
The very fact that we call it that, again, doesn't have any, that's Maxwell's doing. And it's, because magnetism has the same speed, okay, the force moves the same speed as light, then it was decided that we're going to call light a magnetic thing. So instead of understanding them all as just forces, all of the stuff moving the speed of light, just call it force. And it could be in different forms. The one form is gravity, another form is magnetic, and then the other form is light, photons at a frequency. And so the only difference, as I've tried to point out, would be that these little bits come in two kinds, the kinds that affect protons one way and affect electrons the opposite way. So you can just think of them as plus force and minus force if you want to, or proton force and electron force. And they're the same thing, you can just think of them being in a different color. And magnetism segregates those forces, filters for them, causes one force to move one way, and it causes the other force to move the other way, making another magnet quite capable of detecting that change in the force, obviously. And then that force at a frequency, that is, you take the little chunks of that electron force and you put them at a specific distance from each other, they'll do things to electrons. They'll give them a certain kind of momentum that'll make them fly out of an atom or push another electron. And those are the photons, and so that's the electromagnetic spectrum that isn't electromagnetic. It's just made out of the same force. It's just the force is at a specific frequency. And then the last one is gravity. Gravity is the mixed force, and unless it's a magnet, there's no segregation of the force, and all you do is absorb portions of the force and acquire momentum. Both your protons and your electrons absorb the force, convert it into their momentum, and their momentum is much slower. Their velocity is much slower than the velocity of the force they absorb, obviously, because they have to spread it over all of their mass. And so a force that would have gone somewhere doesn't get somewhere, and that has the obvious implication of that thing not getting hit by a force that should have got to it, and therefore the thing not getting hit moves into the vacancy.
We're going to make suspense. Gamma is photons. Gamma is light. Gamma, well, it's very high energy light, but gamma is in some way connected to ordinary light. So let's come to light. Gamma was a big mystery because there were no neutral particles known at that time that could account for the gamma radiation. So gamma was a mystery, and that mystery persisted until fairly late in the very early 20th century, let's put it that way. Fairly late in the very early 20th century. It was, of course, Planck and Einstein, really Einstein, who were the first to understand that light comes in quanta, that light comes in photons. But let's go back.
So let's remember that Einstein, very late in his life, in the 50s, basically said, I've been studying photons for 50 years, and I haven't increased my understanding one iota. So Einstein was not at all confident in his statement, basically saying that he understands a photon. So as much as you can say he did this or he did that or he proved this or he proved that or he did any of that stuff. He certainly wasn't all that confident in his understanding of what's really going on. And that's a real honest and humble statement by him that's pretty much ignored.
Light was sort of the strong case for something which was not made of particles. Light was something which was clearly made of fields. It was made of the
So again, it clearly was made of fields. He says the words, right? So he accepts this duality crap. That, well, in certain circumstances, it's not doing anything fieldy. So and yet he says it's clearly made of fields. So, where's the truth here somewhere? And I guess I'm just arguing that, no, there's nothing wrong with a particle model. It works. You just have to understand that you can't make a photon into a big giant thing. That's why you can have a wavelength of light, or a wavelength of radio waves that can be almost infinitely long, is because the photon itself doesn't stretch, and that the real thing, the on part, the part that makes the up wave, right, is just an on-off. It's either a particle hits or there's no particle, and then a particle hits and then there's no particle. That's what's creating the transfer of the momentum, is a hit, no hit, a hit, no hit, a hit, no hit. And just all you're doing is lengthening the distance between the pieces of energy that are in the thing you're calling a photon.
Electromagnetic field. Okay, the electromagnetic field, electric fields and magnetic fields forming waves when you...
Right, so none of this is explained at all. This field of what, as Ken Wheeler would say, yes, but the answer isn't some sort of stupid thing called an ether, because how does an ether do positive and negative? And so that doesn't explain anything. And what's the ether made out of? What's the structure? How does it do tiny little straight lines and then do stuff that spreads all over the place?
Take a charge, waves get given off. The wave fields are continuous wave fields, at least.
So again, this is just all stuff they made up. So there's no real evidence that you shake a charge and there's waves in a medium. A perfectly valid explanation is that atoms are made of something, and the pressure inside of them are real little bits, and those real little bits fly out sometimes. And if they fly out at a frequency, we can detect them. If they don't fly out at a frequency, they're just a force in the field, and it could affect something gravitationally or in some other way, but it can't affect them in the sense that you can't tune it on your radio.
According to classical electrodynamics, and they give off waves that propagate through space completely continuously. And Newton, of course, had thought that light...
So again, this just totally is defeated by the single photon type experiments. There's no spreading of any wave anywhere. There's clearly a discrete amount of energy, and it goes in a discrete place. And even by their own probability math, they know there's really no probability that it's going to go any of these other places. There's every probability it's going to go in the place they've defined as the place it's going to go. So this is just... it makes no sense.
Was particles. But Newton by that time had been completely relegated to the dustbin, at least as far as the theory of light went. There were many experiments, some of them done by Newton himself, that strongly said light is waves.
So again, they're telling Newton that he has to draw conclusions when Newton's being the good scientist and saying, I don't have enough information to prove any wave theory, and even if I apply to wave theory, there's inconsistencies that don't make any sense. So, and again, they're just ignoring the inconsistency. So they have this wave theory, yet water waves don't do what light waves do in the single slit. Water waves don't interfere with themselves. Water particles don't interfere with themselves. They don't do any of that crap. And how do the photons do it? How do they know they're supposed to split in half when they go through a single slit? There's no explanation for why they would do that. There's just they just make up fake geometry math to say we're just going to split it in half. Here, we just cut it in half. We don't have a reason for cutting it in half. We just did it because we need to create two waves so they can interfere with each other. But there's no mechanical reason why a single slit would break a photon into two photons or two wavicles or two anythings. And there's no corroborating evidence that it happens in any other wave in the universe. So no other wave in the universe meets a single slit and decides to break into two waves. So they have no corroborating evidence of the phenomenon happening anywhere else in the universe, and yet they've made up this special thing that happens. Just like Einstein made up photons being twice as affected by gravity. They just make up something so they can make it fit what they want the evidence to say, rather than what the evidence does say, which the evidence says you have a pattern that has a specific multiple of an angle. The same angle, okay, just multiplied 3 degrees, 6 degrees, 9 degrees, 12 degrees, creating what pattern? The simplest pattern you can create in the universe. On, off, on, off, on, off. I mean, we're going to say that has to be this. No, it doesn't have to be any of that crap.
Not particles. So let's just talk about light a little bit. Electromagnetic radiation. If you take electromagnetic radiation, it comes in waves.
So again, he says it comes in waves when Becquerel already pointed out, no, it goes right where your little straight rays, it seems. It comes out of the little hole, goes in a straight ray, and lands somewhere. It doesn't wave anywhere. The individual photons are not waving all over the place. So he says it comes in waves. No, the single photon experiment, it's not coming in waves. It's coming in one discrete ray. So why do they keep saying this stuff? And one ray's this way, and then one ray comes this angle, and one ray comes this angle, and it just does exactly what we'd expect, over time. The light from the flashlight, each if I could freeze time, okay, into some 10 to the minus 68 or 168, make a little tiny bit of time and just freeze something. You'd say, yes, there's a photon going that way, and then the next moment there'd be one going that way, and then one going that way, and one going that way. That's how it's produced. There's no wave. So their drawing is just made up. What does it have to do with experiments they've already done? The single photon does not wave out of the block. You put a shield in front of the light, so only one photon gets through, very rarely. That one photon is not a wave. It's not everywhere. It's going one place.
So if there's a source of electromagnetic radiation here, an antenna, some form of antenna emitting, it could be radio waves, it could be microwaves, it could be infrared, it could be light, it could be ultraviolet. An atom is a perfectly good antenna, incidentally. Doesn't have to be a big macroscopic tower. An atom with a charge going around in a circle.
So again, it's because they're saying going around in a circle makes a change in the field, when they don't really have any evidence that that's true, beyond the fact that you're moving the charges. You're taking a positive, a magnet, and moving it. Yes, if you move a magnet, okay, a dipole, okay, you'll change where the magnetic end is, but that's all you could illustrate with an electron moving. But even the assumption that the electron is moving is again an assumption. Where did the electron get its velocity? How did they're saying it's held by a magnetic force in its orbit, but they've never explained where it got the energy to be in an orbit. We don't see electrons just buzzing around. We see them ejected by a radioactive material, and we know that they don't just keep going. They don't go very far, and then they decelerate. So how do electrons accelerate into orbits?
It's an antenna. Antennas emit waves. And those electromagnetic waves, when they also fall on a photographic plate or other device which is sensitive to light or sensitive to radiation, will illuminate that and turn it white or black, turn it black, I guess. And That's in the character of light. Now, how do we know that these things are waves?
Well, you don't. That's it. You really don't have very much evidence that they're waves, and your evidence is all because it seems like, because it looks a little bit like. But it only looks a little bit like, and if you do any analysis, any little bit superficial analysis of the experiment, you can see that it's only a little bit like. Sorry, my nerves.
How can we tell that they're also not bullets shot out of the source here? So one thing you might do is do something very similar to what was done over here. Put an obstruction, little hole, and see whether the light is collimated exactly as if it were bullets being shot out of the gun here. With bullets, you would illuminate a little spot over here.
Right, and that's again, and the assumption is that you're using a parallel mechanical system, that it's the same mechanical system, that the weight of a bullet to the mass of the surface is the same as the proportions of the weight of a photon to the mass of all the atoms in the surface it's going by. Clearly not a proportional relationship. So if you said, if I take a bunch of confetti and I shoot little pieces of paper, little pieces of confetti by that same slit, you would expect that because the surfaces are going to have a charge and the confetti is going to have a charge, that the little pieces of confetti would in fact be scattered by the process of being forced through that slit. So if they just used a different analogy, all of a sudden their theory breaks apart. The evidence doesn't match then. So it's all because they've selectively, they've cherry-picked their analogies and their experiments to force a conclusion. And it has nothing to do with doing science and being open and respecting the experimental results, because the experiment results don't have a consistent answer. They have an inconsistent answer, a profoundly inconsistent answer. And you have to work through that. And I would argue that when you work through those inconsistencies, you see that the particle theory wins. It has the stronger evidence, if you honestly look at the evidence.
And of course, what happens is that you don't illuminate such a small spot. You illuminate something which is fuzzier than that.
Well, you certainly don't with single photons. So again, that's just more horse shit. So we already know that, but he's not jumping to that yet.
Illuminated a fuzzy region. But that in itself did not prove that light was waves. Not at all. You could say, well, just maybe when these particles go through this opening here, maybe they have little forces exerted on them by the edges of the hole here or whatever, which deflect them. Some of them get deflected, and so maybe you get a more smeary picture, a more smeary image than you might have hoped for. So it was not just that the beams got deflected, the light beams got deflected. That in itself was not enough to argue for a particle structure to light, or sorry, a wave structure to light. I'm sorry, but you do something else, which is.
So again, he's saying that yes, it's quite possible that they could be deflected by the surfaces and interacting with the surface. But does he pay any attention to what we know about surfaces, which, like with light prisms and stuff, we've learned a lot that the surface diffracts the light. Okay, the light doesn't get bent in a curve through the surface. No, it bends right at the surface. Right at the surface, it bends. And then when it comes out the other end, it bends again right at the surface. And we can see that because we can use it with water tanks, and we can watch a laser beam bend, and it doesn't bend, doesn't curve through the medium. It's right at the surface. It's right at the transition. So why, we already have evidence of this diffraction.
Much more sensitive to the wave character.
Refraction.
Right? Here's the screen over here again. You open up two little holes next to each other.
So you don't need the two holes. So see, he conveniently switched, okay, from one hole to two holes, merely because he doesn't have any explanation for why there would be two photons in here now. Where did the two photons come from to create the interference pattern? There's nothing to interfere with itself. So if he stays with the single slit and explains, well, it really is a bar pattern, then he has to explain, well, why would one photon going through here, how could one bullet interfere with itself? And how could one wave interfere with itself? It's not possible.
If light was simply particles, what you would expect to find here is basically two smears of the same kind, just superimposed on top of each other, maybe a little extra dense in the center where they overlap, but just two smears, one the image of this hole, one the image of that hole, with nothing unusual.
Right, but we already know from the single slit that there's no two smears. So again, this is just kind of a stupid explanation, because in photons we know that's what it doesn't do. So yes, you can make this argument that you'd expect that with bullets. Again, bullets being much more massive than the surface they're going next to.
This, of course, is not what happens. What happens is each hole emits waves.
Says you.
You could do the same trick with water waves. In fact, it's not hard to do the same trick with water waves.
It's very hard to do it with a single slit. So again, you won't get water waves to match the single slit. Then also in water waves, use multi-slits where the whole image ends up being projected at a location. The entire image that you sent into the multiple slits ends up being replicated in all the locations, indicating that if there was wave interference, it couldn't work because the wave interference is supposed to be random, and it would break the images. It would randomize these photons that have to be in just the right place. If I'm gonna put an image of Daffy Duck, okay, in all those locations, he has proportions. The beak is over here, the tail is over there. All of that stuff has to be replicated in the same location, and randomizing it through interference won't be able to transmit images. So we know from multi-slit experiments, from the fact that the multi-slit is basically a diffraction gradient. A gradient basically just recast an image, okay, in different locations, pretty far apart actually. Okay, and it's just an image, another image over here, another image, same image in the different locations. So you already know from that experiment, you can say interference just can't be the answer, because interference won't replicate the image.
And the water waves interfere. If this is the high point of a wave coming out of here, and this is the low point of a wave, places where the high points combine from the two holes reinforce each other. Places where a high point from one hole meets a low point from the other hole cancel each other. And
so the what's really happening is the edge of the slit is just being replicated. So the light photons go in, they get bent, and they get bent at more extreme angles, but it's exactly the same proportion, and it's the photons closest to the slit get bent the same, as the ones further from the slit, for an image to be cast.
So the effect is to see when it hits the screen here, to see bands. Bands of positive reinforcement where the high points add, missing places with no light.
So, and understand, in photons they are in fact bands, where in the electron experiment it's a real wave, in the sense that it's a gradient of on and off, very, that fits what the math predicts, the gradient. The math doesn't predict bands. So this is, again, even their own math doesn't predict what they claim it to be perfect math, and yet it doesn't predict the pattern, because in photons it's not a gradient. And it's also, in their theory, this pattern goes all the way, infinitely, so to speak, the full 180 degrees. Yet they have they have never even put a photographic plate over here, okay, or over here, or way over here, and say how many photons did I detect over here, because I should detect some. So they've never even validated their own experiment by doing the experiment, teasing the experiment, testing it. They didn't do any testing. They just said, this pattern means it's wave interference, even though it's the simplest pattern you can create. And it's obviously a pattern that has exactly the same geometry, implying, just like the hydrogen atom the carbon atom is like a multiple of hydrogen atoms. You can't have like a half of a hydrogen atom inside of the carbon. It's either a full one or no. This is also the same thing, made out of some multiplication, some multiplying of something. So you could make the simple argument that it's just a multiplication based on how many electrons the photon happens to hit as it's passing through the slit. And it will hit electrons because there's always electrons around anything material, because there's protons in there. The electrons are attracted to them.
Where high points meet low points. That's an interference pattern. An interference pattern is a real signal of wave-like motion, of wave behavior. Waves, you can do this, as I said, with...
Well, again, just let's point out, it's the simplest pattern you can make in the universe. So lots of things are going to create the simplest pattern in the universe, right? I mean, sophisticated patterns, like the pattern of my face or something, maybe aren't going to happen too often. But the simplest pattern in the universe, on-off, that's going to be in lots of places. And for lots of reasons.
Water, you just put your finger into water and wiggle two fingers and two ways.
Yes, you wiggle one finger and you won't have any interference. So again, your experiment completely fails. The single slit produces interference pattern, but in light. I wiggle my finger in water, I can't make those waves interfere. So how come? How come there's that inconsistency?
Waves from the two will spread out. Some places they'll reinforce, some places they'll cancel. And so rather peculiarly, but nothing terribly unusual, places which would have been illuminated by either of the two holes by themselves, there's destructive interference, they get canceled, and places you get constructive.
Let's understand the places are exact multiples of the same angle. So whatever event could bend the light once, okay, like diffraction in a surface. If I put a whole bunch of surfaces in a row, I can diffract light a whole bunch, right? If it hits one surface and another surface and another surface, I can bend the light quite a bit. You know, if that were possible. The problem is you can't do that just because the surfaces will never be uneven. You know, the glass will be glass to glass to glass to glass. You have to have glass to air, and when you do that, then it always bends back before it gets to the next surface, and it bends back, and it gets to the next surface, and it bends back again. Because you always have to go through the opposite effect of the exit. The entrance creates an angle one way, the exit creates exactly the opposite angle, undoing the two, giving you a neutral result. So I can't really multiply surfaces to emphasize the point. But the point is that you can imagine it. And so I'm just saying, just imagine that idea. If you could put a bunch of first surfaces in a row, that, you know, the thing would get bent more and more and more. And so I'm just saying that obviously when something's passing through this, by this hunk of matter, this thing with a bunch of protons in it that has a bunch of electrons in it, as I pass by it, through it, I could hit more than one electron. Where if I'm going this way, I'm only going to hit the one electron. So if there's a row of electrons here, I can hit a bunch of them. Where if I'm going this way, I'm only going to hit, well, I could hit two electrons in the sense that there could be two in alignments. Yeah, see, electrons don't like to line up. They always stagger from each other. They don't line up in both dimensions, ever.
Destructive interference, and they add, and you get extra intensity. That is the kind of thing, this interference property was the kind of thing that really nailed the wave theory of light.
Right, and it's a total bogus nailing just because they didn't bother paying enough attention to what the real facts are. The fact that the electron pattern isn't the same as the photon pattern. The double slit pattern doesn't fit the math in another way, in the sense that it's not only predicting correctly the gradient of the light isn't gradient enough. There's also two patterns that they have no explanation for. There's the pattern has another pattern that it's on top of. They don't have any explanation for that. They have no wave interference explanation. You know, so these are real problems, and they just ignored all those to say, well, we want to really make this into a wave, okay? So let's force the evidence to fit our conclusion. So they already had the conclusion, and they're just looking for verification of wave theory, and they weren't fair to the evidence.
So light was a wave. In fact, this did not occur after Newton. It really occurred before Newton. Huygens was a 17th century? Huygens must have been 17th century, but previous to Newton. Who? What? Yeah. Yeah.
No, Young was, so somebody brought up Young, right, which is a totally unremarkable experiment because Newton had already done the single hair, okay, and he'd already done double slit in some other form, and certainly the single aperture, okay, changing the small opening, creating Newton's rings. And all the two-slit experiment is a deviation on that experiment. You're just really seeing a horizontal view of Newton's rings. One cutout of the rings. So the history is really just a lie. I mean, the way they present it. So Young's experiment was totally unremarkable, and yet it's cited as some sort of new insight that was provided. There was no new insight in any way. We already knew the phenomenon. Newton already knew it exists, and Huygens lived contemporaneously to Newton. I mean, he did visit him.
Yeah, but Huygens already had the basic ideas of wave propagation, and that's from the 1600s sometime. So this debate went back, and Newton had done many experiments himself, which should have been interpreted as interference, wave interference, but he didn't.
So he's telling Newton what he should have done in terms of drawing conclusions, when I would argue that maybe Newton, being familiar, actually doing the experiments, maybe was familiar enough with these problems where wave doesn't work either. Okay, so it's just kind of ironic. Here they are preaching to the guy who's the conservative scientist who did science the way you're supposed to do it, which is you're not supposed to jump way ahead of your evidence, and they're scolding him for being the responsible scientist who didn't fall for gimmicks like bent space. Newton wouldn't fall for that one.
In any case, after these experiments, Young's experiment, others, it was definitely confirmed that what...
So he keeps saying it. It's confirmed. It's the truth. It's the nail in the coffin. They just keep saying it, and then they'll go back to playing their duality game because they know they have experiments that just don't work with waves. It's just such bullshit.
Light is made of waves. Okay, what kind of waves? Well, that took Maxwell. Maxwell realized...
Yeah, so Maxwell didn't show us anything mechanically, okay? There's just nothing mechanical in terms of giving you a drawing of it, okay? He gave you these lines of force, which I say should have been a hint to everybody that, that's what it's about, these rays coming off of the objects. But there's no explanation for where the energy comes from, what it's made of, any of that stuff. And Maxwell was an etherist. And, so what can you say? But at least he was, again, responsible. He didn't shove his ether theory into the statement in any bold way. And there's nothing in the math. There's no wave in the math. Maxwell's equations don't have waves in it. They have vectors. They have rays of force. And these rays of force move in very square geometry ways.
That they were waves of electric and magnetic field. You know what an electric and magnetic field is? An electric field...
No, you don't. Nobody can know what they are, because no one's ever described what it is, what this magical field is. It's got to be a field of something. And the something has to be something that's in the universe. It has to be one of these things that we already have identified as being in the universe.
Well, look it up if you don't know. Electric and magnetic field.
Look it up if you don't know. I love that. So, something as important as this is the mechanism that makes it happen. Okay, this is I don't even know how to describe. It's the TV. Go watch the movie on the non-TV. It's the mechanism that makes it possible for any of this crap to happen, and yet they're just totally dismissive of having to explain what the fuck this mechanism is.
There's a wavy motion of electric and magnetic fields. First of all, light is a wave, and here's a wave moving down the axis.
And again, so this is the part where physics, in my opinion, jumped the shark. It left the building. It said, we don't want to make sense. And so when I was a kid, I said, this doesn't make any sense. It's incomprehensible to me. It just can't be the right answer because it doesn't provide anything to grab. There's nothing here that I see as anything but somebody telling me, well, this is the angel, and here's her wings, and this is her pushing the earth. I mean, this just seems like a fable.
What is that wave a wave in? Well, it's a wave of electric field. Here the electric field is pointing down. Here the electric field is pointing up. Here the electric field is pointing down.
Whatever that means. There's no up and down to the photon, I'm sure.
A line through there, alternating electric field, up, down, and the whole thing moves off with the speed of light. The whole thing moves off with the speed of light. Electric field
on, off, and so he didn't draw the magnetic field in here anywhere.
Incidentally, there's also a magnetic field attached
okay.
to the thing.
Here we
It's a
go.
complicated object.
Complicated object. See, again, this is the whole point. All of the phenomenon they're giving to the thing that's the tiniest thing, the thing that we really are going to have a hard time ever seeing, because they because they can get away with it, because we can't see it. And here you have all these solid surfaces that are complicated because there's this relationship between protons, neutrons, and electrons, and there's complex configuration, and that you can create dramatic differences in the material substance. The same stuff, carbon, can be graphite or it can be a diamond, depending on how I move those things. You can have ice and you can have water, depending on how I rearrange those things. And yet they give all the properties to this fucking stupid thing, and they just ignore the fact that matter is full of consequence, that it can affect something because it's doing all kinds of different kinds of things. It has all kinds of different properties. I just change the configuration a little bit of the little electrons and the protons, and I create a completely different functional object. Hard thing, soft thing, liquid, not solid. Completely different by just moving those little bits around. And so they give it no credit for changing anything in the universe, and they give all the credit for anything that happens to this stupid thing.
As magnetic field, also the magnetic field is perpendicular to the electric field, and so it sticks out this way. And that's what a light wave would look like if you could sample its electric and magnetic field as it went past you.
Okay, if you could sample it. We've tried to sample it. There's no sampling. Okay, we can sample electric vibrations. They say. I mean, they're magnetic, of course, and magnetic ones, right? I'm sure we can say we can sample things that have charge, something that's magnetic. And yet they're denying it right here because it's just saying, well, if we sampled it, this is what it looked like. Well, we don't see that. So that's a pile of crap. Photon goes by, we don't see anything unless that thing hits us right in the face. So again, more evidence that it's a particle moving through space, not some sort of thing vibrating through space, because it's not vibrating anything else around it. It's not affecting anything until it hits it. All of its mass, all of its significance, all of its reality, just like a bullet, is in the impact. Doesn't have much meaning unless you're the guy getting hit with it. It doesn't, whizzing by me, it doesn't mean much. I mean, bullets will make a noise maybe. But I'm just saying in empty space there would be no sound, So they'd all be irrelevant. They wouldn't gravitationally affect me. They wouldn't do anything. I wouldn't know they exist unless they hit me. And it's the same is true for a photon. It can't be a vibration in any fucking field because it doesn't do anything that can be detected anywhere else except where it lands. Alright, so since he did the two-slit thing briefly and sloppily and horribly, I'll just point out I have a little list here, so we go through the list quickly. Alright, so they should be called, instead of the two-slit and the single-slit and the multi-slit, they should call them the surface experiments, because that's all it's really about, and the experiment that proves it's all it's about is the single impediment. You put a single impediment, you get the same pattern as the single slit. right? Same pattern. And so what's the key thing? What's the key between this and this? Why are those two things the same pattern? Well, because the thing they have in common is the distance between two surfaces. That's the thing that's the common between the two experiments. Two surfaces at a distance. And that's causing the effect. And we can surmise the two surfaces have to be very close. And you can surmise logically that, well, that means these protons and these electrons are, these atoms are starting to interact because they're charged. The particles inside the atoms are charged, and the charge is starting to be felt by each other. And that means the electrons are lining up, and the protons are lining up based on that pressure. So they should be called the surface experiments because it's surfaces that are doing this. And we already know that surfaces will diffract and refract light. They'll do that. Alright, multiple images. So that gives it away, right? So the multiple slit experiment gives the truth away because a clear image of whatever you send in, a clear image is multiplied in each location. So we know that the same thing is being sent by the same geometry. Alright, electron refraction. So I'm just pointing out, we know that electrons do that. They change the direction of a photon. Photon will hit the electron will do some moving, and in in moving back to its original condition, to regaining its original condition, it will re-emit a photon in a new direction. That's a Feynman diagram. Alright, no evidence of 100 degrees of possibility. So their theory is that this thing should be everywhere. So there should be, this pattern should be duplicated throughout the whole 180 degrees from the slit. Alright, so the surface of the slit, it should be, this whole 180 degrees should have some pattern in it. Have they detected it? Have they looked for it? No. Not the proper gradient from light to dark. The differences between the electron pattern and the photon pattern. So the math says there should be a gradient. It fits in the electron pattern. It doesn't fit in the photon pattern. Clearly different looking patterns. Alright, the experiment's not done, so all of their detector, he didn't talk about detecting in this video, but clearly all of their detection experiments are made up. They didn't do them. Divergence of the beam, I don't know where I was going with that one. So horizontally and vertically flipped, so it's this whole image thing, but the images are not, the images are, they're like a lens, you know, they're inverted. Sine theta is just a multiple angle, so again they make this thing like sine theta is something special. It's just an angle, and it just multiply the angle for each rendition of the pattern. And the simplest pattern in the universe, so single surface diffraction, just pointing out, not the same pattern in a single slit, thickness of the slit. So yes, the one that would be interesting is the thickness of the slit, the thickness of the material you make this thing out of. Now obviously it can't matter with the impediment argument. Well, it can matter. So what's the difference if I make the impediment thicker? You know, if I make the slit material thicker, how does that affect the pattern? What's the theory? What's their theory on how that should affect these waves that are going through the slits? And what would be my theory? And you know, my argument would be that would create more of those bars in those further locations because you'd end up hitting more diffraction. But the consequence of that, most of the diffraction would be into the surface, which means the surface would end up absorbing more of the light. So you would diminish the number of photons dramatically by thickening the material. Now, why don't they talk about that? Why don't they talk about the fact that somehow the slit isn't culminating this wave, that somehow it consumes this wave? Well, how is it consuming it? How does it change the number of photons that successfully get through the slits? So the point is, if I make the material thick, and I put a little hole through a very thick material, I get very little light coming out of the end. Yeah, somehow all the light gets ruined. So clearly, I would argue this almost tells you that this effect has to be happening right at the surface, right at the slit. That there's no time for any wave interference, because if I just took a slit material and then I put another slit material exactly the same right in front of it, and then another one right in front of it, and another one right in front of it to make it thicker and thicker and thicker, you could make the argument that there's no gap between the two pieces I stuck together, so there's no room for any wave interference to happen. There's no place for it to happen. Yeah. Anyway, these are all experiments they should have done, they've never done, and it's just, you know, their foundation is junk for their hard conclusion. Light's a wave, light's this, light's that. They're telling you that's a fact, and their fact is built out of just an assumption, wishful thinking, and cherry picking evidence, clear cherry picking of the evidence. Just pick the stuff that looks like it and emphasize that and de-emphasize the parts that don't work. It's just bullshit. And they're so definitive. They will not have a conversation about this. They won't allow any conversation about these elemental assumptions they've made about reality. They won't allow the conversation to go back and re-debate these subjects. They say they won the debate when they didn't win anything. It's like Einstein and Bogowski and whatever the guy, they send a paper to Bohr, he writes a completely incomprehensible response, and somehow Bohr wins the argument. And no one will go back to the argument. So it's all just such a sham. Alright, well, how far did we get on this thing? 32 minutes, okay. So next time, maybe we'll finish up. Probably he gets too obtuse. By the time he starts talking about antiparticles and all that crap, it's probably a waste of time. Alright, so till the next time and such.